Okay, to finish up our homework, please correct number 1. It should have a 0 in this last criteria for n as well as for number 2.
You mean a 1?
Yeah, instead of the 0, put a 1. Thank you. Okay, and for number 2 here,
0.
Pop, did you fix your number 2 or is it already fixed?
That's right.
Should have 1 there. Okay. So I apologize for my misreading of the story. There's a lot, isn't there? Yeah, there's that.
But the rest are
But
good.
it makes sense. The rest are fine. It's just that if you don't put a 1 here instead of a 0, it'll give you half off.
Oh.
And the reason why you can't have a 0 here, because if I put a 0 in this formula, I get an f of a negative 1. And there's no there's no negative 1n up here. See, that's why I had to start a 1, to make this story make sense. That's why I was wrong. Okay. So I apologize for my mistake. All right? Okay, we got that fixed. And we're jumping over to number 8. We exercised and now we're going to create a pyramid. And if you have your head in the game,
Yes.
you know what to do. You read the story, a large pyramid's made of glass panes. The top row, that's where you start. So this is the f of 1. And you put how many panes you started with. Okay, in your top row. And then each additional row has more panes than the previous row. So you put as your common difference what you add to each row. So that's this one. And here we go. For the recursive rule, if n starts at 1, they've already given that one, so this rule fits for everything 2 and more. So the second term, the third term, the fourth term fits that story that we wrote f parenthesis n minus 1 plus 4. You've got yours? Get your numbers? Okay, your explicit rule then just takes your 8 and you're adding 4, but it's an n starts at 1, so I have to have n minus 1 in my formula for the explicit rule.
How many application on?
And then I start at 1 here. So this number should match this number. And then in your calculator, you're going to use this one because you want to know the 18th row. And this one you need the 17th row to know what the 18th row is. But here, if I put in my calculator 8 plus 4 times 18 minus 1, then I've got my number of panes in the 18th row. This one is the first row, and these are the 17 more rows. So I got 76. Okay. How's your numbers? Great. Good. 2 ones in. Oh. Because you got 15 minus 1.
Oh, sad day.
So just a little bit less there.
Sad day.
And then we
Sad day.
check.
Number 9.
You were 8 too many.
Is that right?
Okay,
No, just. I hope it's wrong.
get rid of that little box.
Yeah.
I don't even know what that is.
It's like a sub.
How do that?
Here you go. Now you're done. Okay, let's find out. Let's find out on number 9. Anybody need help with your number 8 number?
No.
You're happy? Okay. Okay, number 9. We are buying a prom dress. This one's tricky because the dress cost $155, but she made a down payment. So her bill isn't $155. It's $155 minus 35. So my bill starts at $120. Oh, pickles, that's not a zero.
Pickles.
There we go. Okay? Do you see where I got my number?
No.
No.
155 minus 35. So I take my dress cost and minus the down payment before I even get started. So if I start at 120, pay it down, $15 a week. Now this one starts F of 0, so the explicit
There.
rule. Okay, I think you got your, I don't know, I'm not sure about your numbers there on your explicit rule. Watch. I think you're missing something. Yes, so watch. Ready?
Watch.
I'm watching.
Okay,
She could slap you.
it's a 20 minus 15n.
Right. I just
N starts at 0.
wait. 225.
Is 225 too?
Stop, because you're not with me.
So I have to figure out what's gonna make this, to pay it off, this, equation has gonna equal 0. So I take away the 120, yeah, we end up dividing as the shortcut. Negative 15n, and then negative 120. So. Yeah,
Wow.
okay, that was fun.
The answer's
There's a practical application of, I mean, we're all gonna have bills, right? Use some algebra to, so you can stop from getting bankrupt.
whoa. Yes.
On the world.
Go, that last one. This one, we're just looking for patterns. Remember, this is arithmetic sequences, so we're looking for a common difference.
You always say one or no.
Mine's all, I don't know why they're all checky. That's weird.
No.
Okay, don't pay attention to these guys. They have not been decided yet, okay?
Like what kind of pattern?
Well, I'll just erase what isn't, okay? You're supposed to have a common difference between the two. So if I subtract any two of these, I'm supposed to have the same number. So 1 minus 1 is 0. 2 minus 1 is 1. Right there, it's a no. Okay.
Wait.
I take the second one
No.
minus the first one. Okay.
Yes.
Wait. 3. Yes.
Okay, this one is a
1.
Yes.
Minus 2.
so everybody's got a difference of 2, so that one is the yes box.
2.
No. Negative.
So are you guys in the same order minus?
Yeah.
No. Said
Ish.
negatives.
Sometime?
Negative 5. Minus.
So you know how to do you, right? Take the difference. 2 minus 1 is 1, 4 minus 2 is 2.
I think that was yes. Oh man, I'm not good at fractions.
Do we know?
Well, just use your resources then. Use a calculator. See, 3 minus negative 2 is 5. 8 minus 3 is 5. 5. 5. 5. That's a yes. Okay, 2/3 minus 1/2
Yes.
is 1/6. 3/4 minus 2/3 is 9 minus 8, 1/12. So that one's a no.
No.
So the fractions don't fly. They're kind of pretty, but they're not an arithmetic sequence.
I'm gonna have 3 on each side.
I'm sure some mathematician did find some pattern. And the last one, we're going down, 10 minus 17 and a half is a negative 7.5. 2.5 minus 10,
That's yes.
negative 7.5, yep.
I just
Negative 5 minus 2.5,
don't do that, don't.
10.5. Want to check them all, just in case they slipped a Mickey in there. Minus a negative 5 is a negative 7.5. Negative 20 minus a negative 12.5 is a negative 7.5.
She doesn't like it. This one.
Yes. You have observed 3 of each, right? Somewhere in the order in the court.
Yeah.
Anybody need more time on number 10?
I'm gonna turn it in.
Okay, proofread your work, just saying.
Oh, I got.
Oh wait,
25.
I got 100.
Okay.
I didn't.
Uh-oh, spaghettios. Did you fix your 0?
Spaghettios are nasty.
Oh, I
They
put
are.
one number
Oh.
off.
Miss Fisher agreed. She said they are.
Completely non-food.
Oh,
There might be a little vitamin A in
What about ramen noodles?
the
oh my God, ramen. Mm.
You don't like ramen.
Not even the beef ones.
Okay.
Made me
Mm.
hungry.
You drink the broth, skip the noodles. There we go. Okay, here we go. Oh, the lovely.
Eat the noodles.
We're
Oh,
blessed, aren't we, to have such choices.
Oh yes.
Okay, did everybody get this paper?
Yes.
Okay.
Yeah.
We're talking, the rules for geometric series, that means a multiplier. We're gonna have it, you know how the other one was a common difference? This one's called the common ratio. So R is for the common ratio. I call it multiplier.
We showed.
This is how things grow exponentially. And that's why this one is in this unit, because that's our next function. It's an exponential function.
Oh.
So notice where the parts are. It's got them noted there. A does stand for the first term. Okay, R is that common ratio that you find in geometric series. And you won't have to say if it's a yes or no on this. These are all geometric series on this paper. Okay, and so explicit rule has got it right here, short and sweet. You do have to say what n is. You do have to say what n, does n start at 0 or does n start at 1? You know, it just depends on the table if you're going to say what it is. Okay. So the recursive rule, it looks like it's about the same as the other rule as far as having an f minus 1 is, but you also have to say what f of 0 is, and then you have to say what n is greater than or equal to, you know, like that. So you got all that yada yada in the recursive rule. 10. Because once you get it, I hope. And again, if you ask somebody for the recursive rule for the geometric series, very, 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 very few people in this building will be able to tell that without looking it up. But I want you to know where to look. I want you to know their ones exist. And I want you to know what it looks like from a list of numbers. Just like that. And what's the purpose? Remember, we want to be able to predict the future so we can solve problems. That's the point. Or stop disasters. Now, it doesn't always work because there's other factors, pun intended, that play on real life, you know, like eating ramen noodles versus a steak. So, There we go.
So chewy.
It's
So
not
we have
either.
to,
Steak is the appetizer.
we have to know how to set this up.
Cheese.
Okay, notice. Okay. You look at your list. How do you find the common ratio? Well, you can tell from this list, right? 7 times 2 is 14. 14 times 2 is 28. You can't always look at your list and find it. You've got to know the formula to find the R. And here, they use the formula. They took the second one divided by the first one. That's why it's a ratio.
Right.
Or you could take the first one divided by the initial one too. You know, you just take the one ahead of it divided by the one before it. If you take 112 divided by 56, you're gonna get a 2. So there's always gonna be that factor of 2 in this story. So that's what you know R is. You put it in the formulas. You know the initial value comes from the first one on the list. This guy is A. That's where you look to find the A. This is where you get the R. And then you write the story. How many stories you gotta write to get it right, right?
2.
Let's do a couple on here.
1.
Okay.
I'm confident.
Okay, first we gotta find R. We know A,
That's
okay? R, what's 1.5 divided by 0.5?
Wait, hold on. Let me do this.
Please.
1.5 divided by 0. 3.
Okay.
3.
Okay, so, see, that wasn't as obvious as the other one. We're not looking for common difference, we're looking for a ratio. So that's when you set up the division problem and simplify. So it says explicit first, so I look up here. I'm gonna write my story with my A in the right place and my R in the right place. And since M started with 0, I'm just gonna have an N. Because what's any number to the 0 power?
0.
1.
1.
Because 0 means how many, exponent of 0 means how many factors of 3 do you have? None, but there's always a 1. There's always a 1. So that's why this, if it was a 1 up here, guys, we'd have to have n minus 1. That's a silly caveat, okay? So this is the story, n is a 0. My other story is, I'm going to copy f of n equals r is 3, f of n minus 1, comma, and f of 0 is 0.5. We're not going to do this one.
Wow.
And then, comma, yeah, n is greater than or equal to 1. Yeah, there's that recursive. You're gonna take 3 times the term before to get the next term. You started with 0.5, you take 0.5 times 3, you get 1.5. You take 1.5 times 3, you get 4.5. You take 4.5 times 3, yada, yada, yada. Till the cows come home, kingdom comes, however you want to think about forever. Okay? So let's do one that's shrinking. You see how this one's growing? That'd be your bank account, right? Okay, this one's shrinking. Let's hope this one's your debt,
Oh.
right? Let's make this guy smaller.
Get the gun.
Yeah. Okay? So remember how to find R. You take the second one in the numerator and the first one in the denominator. So that's a pickle.
Really is.
Yep. So we are going to have ratios like that. Sometimes they might write them as decimals, but 1/9 is not a nice decimal. So we're going to keep it a fraction. So my explicit A times R to the n power And my recursive is a lot, yeah. The first one isn't, it's just f of n minus 1 time, my r needed to be in front, 1/9 needed to be in front of that.
So,
Squeeze it in there. And then, comma, I started with 162. Am I still on the screen? Yeah. Comma, and then for everything after 1. Because we started with 0 up here, so recursive is a 1 there. See, it's like the arithmetic, but these are kind of a different order. But we're multiplying in this lesson. Can you do that?
yeah.
There's the 3 formulas in a snap up there. How you write the formulas. I don't have the rest of this yada yada, but that's pretty routine. Take the first term and let's play the game. It's drag and drop. If you're ready on your homeworks.
Did you finish the whole lesson today?
I didn't this morning, but I did a lot of yadding. So we got 9 minutes. We'll do our best. We'll do the best we can. How's that sound? You'll probably finish it without me. Because you know the routine. I need an A and I need an R. Second one divided by first one. So A goes, yeah. If you look at my A goes first, and my R goes here, and then my R goes here, and then my A goes here. See, this is A, R, R, A. Find yours. I like geometric sequences. They're interesting. You ready for the next one?
Yeah.
Okay. Remember, this needs to be A, this is R, this is R, this is A. So I find R, this is A, 20 over 200, and it looks like it has to be in decimal form. So you know how to make your calculator sing decimals versus fractions, right?
No. Second.
Okay. Yep. You can, or use the arrow. Okay, okay, like I put this guy in, ready? Okay, I got it's this guy right down here, this little sideways toggle button, whatever that is. It'll take it to a decimal, okay? So 200, 0.1, 0.1, 200. So it's A and R instead of A and D. See, relationships. We can do it. Oh, this one starts with the number 1. So that's a pickle. You see how the power changed to n minus 1?
Yeah.
Yep, because of the, this is still A. R is still 700 over 7,000, which is 0.1. So A is still here, R is still here, R is still here, A is still here. $7,000. where this, we have no idea where this data comes from. They're counting something, and it's disappearing. Might be the height of the grass on the prairie, who knows? Calculating how many years it'll be before the
Oh, wait.
grass disappears. Oh, okay, can you make your calculator do this?
Yes.
Okay. 10, 70, and I would just divide it by 10, oh, wrong, 68, sorry, 68 goes on top. But it won't change it to a exponential easily. So what do you get? 0.01?
Yes.
Yeah.
Okay. So test which one of these in the calculator give you that same decimal. Put in 10 to the negative 2 and change it to a decimal. Yes. So A, R, R, A. 10 to the 70th, and 10 to the negative 2. 10 to the negative 2, and 10 to the 70th. Those are big numbers, but it comes in handy. Gotta know a little bit about your exponential laws, how to make different forms of numbers. Kind of a big deal. That's supposed to be a 2. Can read it. There we go. Okay. Halfway through. Ooh, you guys gonna have fun plotting points. Very rarely do I have graphs, but this one we will. We will. We're not afraid. We're not afraid. We're gonna watch the curves happen, and I hope your iPad behaves. Okay, give the explicit rule for the geometric sequence. Given the explicit rule, use a table to generate the values and the first 3 points in the graph. Okay, so they want us to put a 0 in here, so we're gonna get a 1/4 out. Will they let you type in 1/4, or do you need to, will it let you? Will it let you put in a fraction?
No.
No, so we must put in a decimal, 0.25. So this one right here really means 0.25 times 4 to the nth power. Okay, so what I did was put a 0 in here, right? It just went to 0. So if I put a 1 in there, 4 times 0.25 should be a 1, right? Yeah. Check it out.
It's not letting me type.
On, clear, it's not letting you type it all. 0.25 times 4 to the first power, okay? Then I gotta do 0.25 times 4 to the second power. You know how to put that in your calculator? Raise your hand if you need support. Like that. I got a 4 out. Okay. And then just grab it and put in the third power. Make the calculator help you.
Oh, wait, am I doing
Yeah.
Or am I-
You're doing mine.
Let me check answers.
Uh-oh, you're doing mine?
Yeah.
Oh, pickles. Sorry. Okay, so I can put in here, just back it up to put a 4. And got those done, 64. And now we're gonna put in, you click this, and then you're gonna have to go up a quarter. So you gotta be a good eyeballer here. And then the 1 goes to a 1, and then the 2 goes to a 4. So do your best to get a 4. This one's gonna be the challenge. Is
Wait, why does it do?
Ooh, you have, ooh.
ugly numbers.
Ooh. Ooh. Oh, well, it is what it is, right? So all you have to do is put 0.251 and 2.25. So you hit this one, you hit your, if you can get it, that's it. Yeah, there you go. And then you just go up 0.25 on the, you know, that zero go up just a quarter. Okay, grab it. Oh, good job.
And that's it.
So, well, then you gotta do the one, gotta do the next one, 1, 1. Okay?
Wait, one
So,
right here.
hit, right, you gotta
Oh.
get that one, okay, and then do, yep, right, get that on the bullseye. Save, always go to the next problem, come back, sometimes that helps. Yep. There you go, and I'll slide it so you get crosshairs on the point. Perfect. Okay, and then 2, you gotta go 2 1/4.
So up. And then
Yeah,
up.
up a quarter, yep,
And here.
there you go.
Like right there.
Just a little bit up, a little bit up, just a little, just cause you're gonna go a fourth of the way. Yep, I'm feeling it, what do you think?
Yeah.
Is it quite, okay. So if you try to graph, and they're close, and it counts are wrong, I will override this one. Okay, it needs to be right on, oh yeah, that's a quarter. Okay, go to the next one. You got a 1, 1, right? Okay, looking, oh, you see this? Just on the 1. Yep, okay, and the last one, what's yours? 0.5, or no? Oh, yours was 0.5, huh? Ooh, sorry. You have a different, okay, go back. 2 is here, yeah. No, that can't be right. Oh, yeah, that's right, cause you gotta make that one. Yeah, perfect. Okay, there you go. All right? So how are we doing? Oh, we're way over time. So, we will finish the second half on Monday and be on to series, which is another whole interesting relationship.
It is